Really quickly, we normally do an intro slide, but it was pretty taken care of better than I probably could. Really quickly, SensePost is a small information security consultancy based primarily in South Africa, even though we do most of our work out of it. We've been around for about 10 years, do work all over from Geneva to Gaborone just about. Do training around the world, released some papers, written on a few books. We've spoken at Hack in the Box a few times, although it's my first time here. So really quickly, if you take a look at this talk, the first question that comes up is why this talk? Okay, why are we interested in cloud security? Probably one of the big things right now is that cloud's a real headline stealer. Okay, the moment you put cloud on your talk, it's bound to generate some buzz. But what we wanted to capture is that SensePost as a company has been around for a while. Okay, so we don't normally go for the talks that are immediately headline steely. In fact, we've got the dubious honor of having some of the slowest tools in the world. I think last year at Hack in the Box, we published a tool or released a tool that tunnels stuff over timing, probably one of the slowest tunnels in the world. Okay, so really, generally, we go for what works and what attacks are pertinent, but we still felt that there's something big going on with the cloud and that there was some reason we needed to focus on this. Okay, and one of the big things that we wanted to bring up is that right now there's a lot of loud in cloud security. Okay, there's lots of people talking about it, there's lots of arguments about it, and in the security sector, there's lots of people who are immediately down on it. Okay, the moment you talk cloud, you've got a whole bunch of people shouting about how it's nothing new. Okay, Marcus Ranum screamed about how it's the same old thing. Schneier's given several talks where he's pointed out that it's the same client-server computing paradigm from mainframe days. Okay, what's interesting is Schneier's given about 4 or 5 talks saying that it's exactly the same thing. That's a lot of talk to say that there's nothing worth talking about. What's interesting for me is that if we stand around splitting hairs, there's a good chance that we're going to miss something important. And if you're defending, or even if you are testing, you'll find that there's several new vectors that we need to be aware of here. Okay, so the first question that comes up is, what exactly are we talking about when we start talking about cloud? Okay, you can get the Wikipedia article definition, okay, scalable, often virtualized, elastic computing, blah, blah, blah. If you look at guys like the Hoff, he's put together a very detailed diagram of all of the different possible cloud computing paradigms, where stuff fits in, all of that. We're not going to go into that in this talk either. Okay, what we're seeing cloud computing for our intents and purposes here is really simple. We're saying, what can we as attackers do? Okay, and what you see typically is there's boxes we can attack, applications we can attack, or storage we can attack. Okay, and what we'll do as we go through the talk is look at examples of these attacks that we've carried out during our research. Okay, the question then is, why would we want to break the cloud? Okay, quite simply, right now we want to break it because that's where the action is. Okay, and what you'll find is increasingly more and more services will be moving to the cloud. And you'll notice point 2, we say it's insidious because lots of times you don't even notice that your data is being moved to the cloud. Okay, suddenly you'll find your data isn't quite under your control and you didn't see it happening. Interestingly enough, as we move to the cloud, we seem to be making the same old mistakes that we were making in the past, along with a whole bunch of new ones. And one of the things that we want to come out of this talk is that we really don't have to. Okay, the initial part of my talk is a little bit of background, so I'm going to go through it really quickly so that we can get to the examples. Okay, so the question is, why is cloud adoption happening? The first excuse that everyone gives is because of management by in-flight magazine. Okay, some manager's flying somewhere, reads a magazine article about how cool the cloud is, comes back and demands that his technical guys do it. Okay, interestingly, we all blame managers really quickly, but the techies are guilty of almost exactly the same thing. Okay, the cloud computing stuff is cool. If any of you have played with EC2 or AWS, it's one of the coolest things that I've played with in a really long time. And so you've got managers saying, I read this article about cloud security. You've got geeks saying, this stuff's really cool. There's nobody to put the brakes on it if it needs brakes. There's also a really poor history from IT on delivering on services. Okay, so if you look at Salesforce.com, essentially they're providing outsourced CRM. It's really telling that someone would go and give their CRM to someone else because they couldn't get the CRM up and running internally nicely enough. Okay, with the downturn in the economy, cloud computing becomes attractive, again, because it's allowing you to make your payments as CapEx. Quickly, there's some talk of private clouds. Okay, we're not going to cover private clouds in our talk at all. Essentially, one of the big attractors to cloud computing is multi-tenancy because of cost saving. Once you go to private clouds, you don't have that cost saving advantage. It's not what we're interested in right now. So really quickly, if we start looking at problems you have when you're testing the cloud, probably one of the biggest problems that pop up is a question of permission. Okay? How do you get permission to test something on Amazon's EC2 when the results of your testing could show you data from another client completely? Okay, one of the big problems you have is the risk of getting blackballed. So I use Amazon a lot. Almost my whole salary gets transferred every month from me to Amazon because I use them a lot for books. When we were doing EC2 testing, one of the things I was really worried about is what happens if Amazon kicks me off their system. Okay, suddenly I'm not able to buy books from them. And if you're on EC2, it could mean a lot of other things. When you're in the cloud, one of the problems that you have is how do you track versions? How do you do regression testing? Okay, how do you know what version of their search engine Google's currently on? And if you test an app today and you find it not vulnerable or vulnerable, how do you know that the app you're testing tomorrow is the same one that you tested yesterday? Okay, you don't. And for someone who's putting all their eggs in someone else's basket, it leaves you with a simple problem. You just don't know whether the app that you're looking at is the one that you tested and was okay. It underlines something, which is the problem with transparency with the new cloud computing paradigm. And this transparency problem comes up again and again. Fairly recently, Amazon had a problem with their Kindle book where they pulled off George Orwell's book from other people's Kindles without asking them permission. And Professor Felton said that the biggest thing going forward for Amazon will be making sure that they get customers' trust right. Okay, and it's something that's going to come up consistently. So if you notice, the guy up there is Guido van Rossum. He's the creator of Python, who now works for Google. And you guys will know that Google are putting out App Engine, which is Google's play into the cloud. When you talk to Guido van Rossum, recently Cloud Security did an interview with him. And basically they said, well, how should our people trust you? And he said, yes, I think trust is built up over a long period of time. I think the main thing is going to be trust. So Cloud Security said, well, what security principles did you follow? And he said, I can't share any specifics on what we're doing. So they said, okay, can you give us examples of how they played out? And he said, sorry, we don't divulge any information like that. So they said, okay, how do you contain an attacker? And he said, you're correct, we do, but we can't tell you anything about it. Okay, so for transparency, that's pretty much a fail. If you look at compliance in the cloud, RSA, one of their strategists recently said, if you're dealing with data that doesn't have compliance issues, it's cool, go play in the cloud. If you have compliance issues right now, there's no way for you to do this. Okay, which is certainly going to be a problem. Okay, which also brings up the questions of privacy once you're dealing with the cloud. Okay, Jim Dempsey from the Center of Democracy and Technology pointed out that there's a loss of a Fourth Amendment right. So in the States, if someone captures your data, some government organization requests your data, they've got to issue some sort of subpoena, something that says, hey, we're looking at your data. It turns out right now, if your stuff is hosted at Amazon, they don't have to tell you, and what's worse, they can tell Amazon to not tell you. Okay, so your data currently sitting in the cloud, they have to issue Amazon with papers, not you. So you don't even know when your information is being looked at by someone else. So normally, the moment you talk about this, the first thing that people scream is, use crypto. Okay, throw some crypto magic on it and everything will be okay. Okay, the guy up there is Robert Morris, Senior. He was the chief scientist for the NSA for a long time. He's a crypto demigod. And Robert Morris once said at a talk that if you think crypto will solve your problem, you don't understand crypto or you don't understand your problem. Okay, and basically what he's pointing out is it's not a turnkey magic solution. And if you're looking at services in the cloud, I'll pick on Amazon again, you have to ask yourself, if you're doing this crypto on a system that's owned underneath, do you actually know what you're getting for your crypto? Okay, another generic problem you have is vendor lock-in. Okay, it's pretty self-explanatory. What happens if your relationship with your vendor dies? How do you get your data off that system? Okay, you'll find lots of professional photographers don't even use Flickr because they don't know who the data belongs to once you upload it to Flickr. Okay, there's some conflict of interest. It turns out that while it's there, Flickr owns that data. Okay, RMS came out very strongly, one of the open source zealots. He basically said, if you're using cloud computing like this, the stuff's out of your control. You might as well be using completely closed source software. You putty in the hands of the vendor. Okay, one of the other things that you have to worry about is availability. Even though one of the big promises of cloud computing is that you now get massive availability because these vendors know how to do availability really well, the big guys fail also. So while we were working on this talk, we found that at some point Cloud Files, which is Rackspace's cloud, went down. During that time, while using SugarSync, we found SugarSync closed for maintenance. And even the really big guys like Google App Engine had several times where App Engine went down. Okay, what's interesting to note here is that this stuff's completely out of your control. When you have your own guys working in your own server room, you can kick someone to make sure that they don't have downtime when you need it. Okay, right now when you're working with one of these big vendors, your name in the line, and if they decide they need maintenance, there's very little you can do about it. The question of availability is not just one of uptime. Okay, if you check out USA, who are a cloud storage provider, at some point they change their page to, sorry, we've been acquired, all of your data will be available once we finish going through our legal stuff. Okay, that's my data, suddenly I can't get it anymore. If you go to TechCrunch and try to look up who the big names in online storage are, they have a few of them, and you'll see down there in green, they list OmniDrive as the big players. Okay, you go to OmniDrive, and OmniDrive says, sorry, we no longer available, we recommend Nomadex. Okay, and this is not even OmniDrive. OmniDrive's gone. These other guys just bought their domain so that they could get a good referral. Okay, and if you're looking at it from a testing point of view, there's other things that affect availability. You can think of it really simply. If you use Gmail for your email access, and I were to go hammer away at your login and lock out your Gmail account, how do you convince Google that you're you again? Okay, it's a really simple attack that can be extended to any of the cloud paradigms that people need to be worried about. The next big thing that comes up is the question of monoculture. Okay, so all of you should know that picture. Okay, that's Dr. Gear. Just viewing that picture generally means that all of us get a little bit cleverer. Monoculture Gate was really big a few years back. Okay, basically, Dr. Gear and a few of his colleagues published a paper that said that our increasing reliance on Microsoft systems built a monoculture that was basically setting us up for cascade failure. Okay, he said we're using the same platform across, we're going to be in trouble. Everyone rallied to his call. And in fact, lots of people did it just because of the normal anti-Microsoft hype. Now what's interesting is, with cloud computing, we're heading for almost exactly the same paradigm, but you don't get people making that same call. Okay, if you take SmugMug, SmugMug's one of the poster childs of cloud computing. They do all of their processing on Amazon Web Services. They launch close to 2,000 instances on Amazon Web Services with a single call. Okay, now I want you to think about that. That's 2,000 boxes, not that are kind of looking the same. They were created of exactly the same image. That's 2,000 images that all fire up the same way. if you want to talk about monoculture, you don't get a lot monoculturer than that. Okay, it becomes something that's interesting for us when we're attacking. At this point, I have to mention one of my incredible fails while we were doing this testing. We were interested in whether address space layout randomization would be affected if you booted multiple images at the same time. So on Amazon, you can get Win2K3 images. So we wrote a script to fire up 20 images, note the address space, fire up another 20, note the address space. And we were astounded because we found large parts of the memory space were common, which meant attacking would be easy. And we thought we were onto something big until someone pointed out that Win2K3 didn't ship with ASLR, so it was supposed to look exactly the same. Okay, so really quickly, one of the other problems with the cloud is you're going to extend your attack surface. Okay, we already know that if you're running an organization, you've got phishing problems. Okay, what happens now is your phishing problems extend to your vendors. Okay, already we've had cases of Twitter users getting phished and their stuff being used. We've had Facebook users getting phished. We've even had Salesforce.com, where administrators were phished, which led to their customers' data being leaked, which then became a big problem. Okay, you can control this when it's in your own organization. What happens now when it's moving to somewhere you don't have any control over? The other problem is, currently, we're putting all our eggs in one basket. So in the past, if you got phished, or someone in your company got phished, at best, someone got access to their account. What theoretically happens now is if the right person gets phished, we get access to 2,000 boxes of SmugMug's network. Okay, a simple phishing attack can suddenly translate to something that's a lot more dangerous. It becomes then a question of trust. Why would we be trusting these cloud vendors to handle security for us? Okay, and the moment you talk about trust, you normally get a response like this. Okay, so I was talking to Ben Nagy about Kostya from Immunity's VM jailbreak attack, and he pointed out how scared he was of an attack like Kostya's. Now, Kostya's attack is really clever. He basically allows you to go from guest to host inside of VMware. But what I was pointing out is, we're really scared of someone like Kostya, who's a 1 in a million person. How do we know that Amazon haven't Trojaned their hypervisor natively? How do we know that we're working on a computing base that we can trust? And the normal response is, hey, you have to trust someone. We trust Microsoft to not put something sneaky in the operating system. Why won't we trust Amazon? Okay, but this is a red herring. It's a little bit false. And the reason for this is, if you look at the normal saying, it's trust, but verify. Okay, once someone gives you their OS, you have some way of verifying it. Reverse engineers, in a way, keep Microsoft honest. If they hide something in code, it's only a matter of time before someone finds it. Okay, even guys who've been putting out Trojan or pre-owned hardware, sooner or later someone reverses it, someone finds out that there's something sneaky under the hood. With cloud services, you just don't know. Okay, if Amazon put in a dodgy hypervisor layer, you don't know that they did. And if they let you test it today, you don't know that that's the same one you're working on tomorrow. Okay, because tomorrow they could change it and you wouldn't be any the wiser. Okay, and that's why we say, even if the guys do no evil today, we can't trust that they're going to do no evil tomorrow because we've got no way to verify it. Okay, so one of the questions that come up is, yes, but aren't you getting a bit tinfoil hatty now? Okay, and for those of you who are old enough, you'll remember this crypto AG problem. Okay, there's a company called Swiss AG, which was selling crypto to about 150 countries in the world, and it turned out that Swiss AG was just a front for the NSA. Okay, and they were selling deliberately weak crypto to lots of places, and at the time it was discovered with the Iranians. Okay, so one of the things that you need to consider is, with the move to cloud, it's almost synonymous with a move to web applications. And we really haven't got the web application security problem down yet. Okay, so we're still building vulnerable web apps, and now we're starting to tie infrastructure to those vulnerable web apps. If you guys think back, in the very recent past, we've had security problems on Twitter, we've had cross-site scripting worm on Twitter, And all Twitter have to do is take 140 characters and show it to your friends. Okay, they've got a really simple application, and they couldn't do web application security right. When you start looking at something like Amazon EC2 with that many moving parts, you're going to find that it's a big problem. Okay, really quickly, if we look at other uses for the cloud for possible evil, you'll find that some attackers, hackers have been really quick onto it. For those of you who remember the Debian disaster a little while back, there was a bad commit into OpenSSL which led to weak SSH keys. And basically what Dino Dazovi did is he used Amazon's cloud infrastructure to generate all of these keys. So essentially he got a whole bunch of computing done relatively cheaply. For about $16, he generated all 500,000 possible SSH keys. Okay, it's really clever, it's computing on tap. Ben Nagy is using the cloud for fuzzing. He did a talk at Syscan. Basically what he's doing is iterating through Office fuzzing. And by moving it to the cloud, he's able to scale it, where previously they were doing a couple of tests a second. He's doing now multiple tests, and he can scale it as much as his employer wants to. Zynamics, so that's Halva and his company, are using the cloud to do malware classification. David Molnar and friends. Basically, the takeaway from this is that suddenly there's a whole bunch of computing power available on tap to attackers who can use it creatively enough. Okay, so problems that was previously constrained by CPU become less so now, because now I can get a lot of CPU basically just for a little bit of money. Okay, so during our testing, we looked at a few vendors. We didn't have a lot of time to go through all of them. And the ones that we decided to focus on were Salesforce.com, because they're probably one of the biggest CRM vendors out there. Apple's MobileMe, because it had some interest to us. And Amazon.com, because of their EC2 AWS services. Okay, so we'll go through examples of all of this now. One of the biggest promises of cloud computing is auto-scaling. Okay, essentially what they're saying is, if you look at how your computer usage goes, there are times when nobody really needs your service. Why should you have 3,000 services? You can dynamically scale so that when you have 10 users on your site, you only use this, and when you have thousands for the slashdot effect, you automatically scale. Okay, which of course should set alarm bells off in your head immediately. Okay, because auto-scaling, while it's a big promise, also has very obvious downsides. Okay, so in crypto circles, it's already relatively well understood that if your attacker can make you do a lot of work, by them doing a little work, you're well on your way to getting DOSed. Okay, it's something for us to consider when we start considering applications in the cloud. So a long time ago, or about a few years back, Amazon introduced something called SimpleDB, where SimpleDB basically puts a database in the cloud, and they charge you for every transaction that you do using their database. Okay, it's a good model, it seems reasonable, and you can see it's a move towards where content is king. So you don't need to know anything about SQL anymore to build an application that lives in a cloud. You can use SimpleDB and it's relatively small. The question is, what happens if I just do repeated queries on your website? So I just keep saying, how much is the pink shirt? How much is the pink shirt? With every request, you keep getting charged for this. Okay, and Amazon's not going to say anything because they're happy as long as you keep getting charged for it. A little while back, Schneier and a few other people started talking about the problem of incentivization in security. Okay, who's incentivized to make the fix? And when you talk about this auto-scaling problem, people quickly point out that click fraud has been around for a while on the internet. If you look at Google's AdSense, one of the problems they have is click fraud. Okay, but there's a subtle difference that's important. With click fraud, the system almost self-regulates. If I keep putting useless clicks on your advert and you get charged for it, your ratio of adverts to conversions fall, and the value of that ad falls, so you'll pay Google less for each click on each of those adverts. With Amazon SimpleDB, there's nothing that corrects the system. Okay, we keep clicking, you keep paying, Amazon keep collecting. It's one of those things that we're going to need to fix as we go forward. Storage as a service is really big right now because it's really simple to build a storage as a service solution. Basically, you offer disk access on the internet, and generally you have some sort of client that accesses it and some sort of web front end that allows you to get to it. Okay, which should immediately make you take a second look, because web apps and file systems these days mean that we're almost back in 1990 with NFS. Okay, way back in the 90s, if you were doing a pen test, chances were good that you'd find an NFS store to remotely allow you to get access to people's disk. That whole thing went away for a little while, and now with storage as a service, we've got ways to access people's disk, again, just through a web console. Okay, so I'll blitz through two examples that are not ours. F-Secure recently bought an online disk storage crowd called SteekR, and their whole push is that they do secure storage as a service. Okay, while the announcement was still fresh, Russ McCree from Holistic Security found that if you just named the file an XSS string, effectively you'd get XSS on the application. Okay, how far you take the XSS depends on you. Apple's Mobile Me, Jeremy Richards took a quick look at it, and he found that if you just inserted .. okay, so old directory traversal, when accessing a folder, you could get directory listings of files that were not in the public folder, so private folders. Okay, and if you sent your request well-formed, again, just with the .. essentially you'd get access to anyone's private files sitting inside of Mobile Me. Okay, what else is interesting about this is that this happened in the last 4 months. Okay, now Apple's Mobile Me is disk storage that Apple say you can happily use. There's some big names using Apple's Mobile Me. The problem came up, the problem was fixed, and nobody even knew about it. Okay, you get this by going to Amazon's Apple's security page and getting their list of tester credits. Okay, so all of the data on Mobile Me was available to anyone who inserted .. in the request, and nobody knew about it. Okay, so we start to take a look at SugarSync, which is another Mobile Me solution. But before we do that, we've got a few minutes. I'm going to do a quick diversion into one of the things that we thought would be hopeful for testing in the cloud. Okay, so for those of you who've been here before, one of the tools that we released a few years back was a tool called Crowbar, which does generic brute forcing on the web. Okay, and the reason why we built it was because if you take a look at a typical web application, in this case, we're trying to brute force the username. So we've got username Bob, password cat. It sends back a message that says, sorry, your password's incorrect. Okay, we go again, Bob, password dog, sorry, your password's incorrect. Okay, Bob, password fish, it comes back and says, okay, you cool. If we were building a brute forcer for this, the really simple approach is send your request and look for welcome, and once you find welcome, you're now good. Okay, the problem is, what if the application doesn't send back welcome? So you've never logged in before, you don't know what a good response looks like. Okay, and what Crowbar did is, Crowbar said, okay, first we'll send username Bob with password, this can never be right. You get a response, we take a page signature of that page. After that, when we send a request, basically we just take the response and see how similar the response is to the first response. So we can generically tell that, hey, you look a lot like the error message, you probably not our guy. Hey, you look good, so you probably are now logged in. Okay, one of the problems, of course, is if we do this, we're going to start to bump into account lockout problems. Okay, but brute forcing on the web is still attractive because what we can do is brute force usernames instead of brute forcing passwords. Okay, so instead of Bob password, Bob password, Bob password, we choose one password and iterate through all the possible usernames. Okay, at this point, it's not going to log you out or lock you out because who's it going to lock out? And sooner or later, you'll bump into a valid username. Okay, the other way brute forcing still works for us is once you get a valid session, okay, so someone logs in, good username, good password, they get back a session ID. The session ID is then your identifier for all subsequent requests. Okay, so essentially what we could do is cut this out and just make the request for balance using the session ID. Effectively, we're not iterating through username or password anymore, we're just iterating through session IDs. And of course, this becomes attractive to us because if we now have a cloud computing model, we can scale across all these computers to make all of these requests for us, and it's costing us very little. In fact, if you're attacking a service that's built on Amazon Web Services, then all traffic from Amazon Web Services to Amazon Web Services is free. So you can build your brute forcer in the cloud and not pay for any traffic while you brute force attack someone. Okay, so this was one of the things we wanted to do. So I ported our old Crowbar so that you now have a cloud version of it, so that Crowbar now lives in the cloud. You can click a button and say, bring more friends. It basically invites other cloud computing accounts of yours. So instead of one Crowbar account, you now scale this across as many as you want to pay for. The problem is that I was wrong. Okay, so if you take a look at, while the screen adjusts, if you take a look at our first example, which is basically SugarSync. Okay, so if you go to SugarSync and go to request a I forgot my password, essentially what happens is they say, okay, we're going to mail you back your password. Okay, so time goes on, you should see the email coming through down there, which is a simple one of those reset links. Okay, you take a look at the reset link, it looks something like that. You click on that link and it now allows you to go reset your password. Okay, what's interesting for me as an attacker is how small that secret portion is. Okay, because essentially it gives me hope that I can brute force through that space. Okay, so what I'm hoping for is to go reset someone's account, that link gets sent to them, and then using my new cloud tool, I'll brute force through that space till I find the correct URL that will allow me to reset his password. Okay, does anyone know how I was wrong about this? Anyone? Okay, the simple way that I was wrong is, that my slide didn't work. The simple way that I was wrong is, even though that looks small, it's still a pretty big space to iterate through. Okay, it gives you 35 to the 12 possibilities. You're still not going to brute force through that easily. Okay, even if you use the birthday attack, you're still dealing with a number that's too big because that link is active for 2 days. Okay, so I visit them, I say, I want to attack this person, he forgot his password, they send the link. I iterate through those so that they send him lots of links. Okay, but still, they can't send me exhaustively through that space in the 2 days that I have to test. But during the testing, I've already gone down this route. I really wanted to break into them, so we kept trying. So we generated a whole bunch of requests, hoping that we could find some weakness, some predictability in that number, and it turns out actually we couldn't, and so that was a fail. But while we were doing this, we figured out something else, that we could script the account reset process fairly easily. Okay, we use Twill for this. If you haven't used Twill for web app testing, you should Google it, download it. It'll save you a lot of time. But basically what we figured out is if we scale this across EC2, we could get something like 2 million I forgot my password requests sent inside of 2 days. So we did to see if they'd notice, and they didn't. Okay, so basically if you imagine this attack plan, I want to break into Bob's directory store. I go in, I say Bob forgot his password. I say that 2 million times, and so all the time they're sending valid links to him. And at the same time I'm running Crowbar guessing for valid links. So I'm attacking the problem from both ends. On one end I'm creating a lot of links that should be active. On the other end I'm trying to find a link that's active. Sooner or later I find one that works and I can log in. Okay, at this point I'm really stretching. But what's interesting to note is while we were doing this testing, so we did it, we went through it, they're already making a mistake in that they're not detecting that we're pulling this attack off. Okay, and something that's interesting to note is this becomes a problem more and more when you look at cloud computing, is that you're not even aware that you're under attack. Okay, in this instance, we go back and look at our SugarSync email folder, okay, and we go back and we find here's all of the mails that were sent to us with valid links for us to go back and reset our password. We take a random one, okay, and it turns out that that link is still active. So we can go back and reset our SugarSync password. What's interesting for us is that at this point, if you look at the email date there, that link was generated on the 2nd of July, and our current date at the time of this testing was the 16th of July. So it turns out that those links are valid forever. Okay? So SugarSync weren't resetting the count on that thing. So we could now categorically just keep running generating forgot password links, keep going at the other end, and you guarantee that you'll eventually find a winner because nobody's going to notice that you're even doing it. Okay, which takes us to the next thing, which is platform as a service. Okay, and in this case, we want to look specifically at Salesforce.com. Okay, if we take Salesforce.com as an example, I'm going to blitz through this. They do both software as a service and platform as a service. Okay, we decided to take a look at their web application, and one of the first things that we found is that their applications are vulnerable to clickjacking attacks. Okay, at this point, we're doing really simple cursory testing because you bump into the problem that if Salesforce find you doing nasty stuff on their site, Salesforce is going to kick you off. Okay, we've got a video of the clickjacking attack, which I'm going to skip. All of you know what clickjacking is. Jeremiah did a talk here last year on it. If not, I'll make the video available shortly. Okay, and the reason I'm moving on is because we've got much more attacks than the time's going to allow for. So Salesforce have a problem in that Salesforce have a multi-tenant model. Okay, so multiple people all have their accounts on Salesforce.com. It's a subscription model. They also have some sort of app exchange. So people write apps and then you integrate their app into your CRM. Okay, already that should sound like a pretty bad idea. And one of the things that we enjoy as testers is they give you free dev accounts. So you can sign up for free and test Salesforce.com for free. Okay, and one of the first things that we wanted was to see how we develop an app for Salesforce. Okay, and they have a really simple to understand HTML templating language which you can use, and they have a Java-like language called Apex. Okay, and this is all custom that you've got to learn if you want to build apps for them. They also do their own type of SQL, which uses ORM, which we won't get into right now. You do your dev in a browser or through an Eclipse plugin. Okay, it's a really robust programming environment. For us as testers, basically if you look at the interfaces that are open to you, if you write an app that lives in Salesforce's cloud, you can then create SOAP endpoints, you can make HTTP requests, you can send emails out. Okay, and basically what we were looking for as attackers is if this multi-tenancy model exists, how can we as an attacker start to steal more than our fair share of computing time on Salesforce's cloud? Okay, all of this testing was done by someone much cleverer than me. So if you have any questions, you're going to have to go to marco@sensepost.com. Basically, Salesforce have something called the governor, where the governor sits and tries to make sure that one person doesn't use more computing resources than they should. They limit this on a whole bunch of things. So you're only allowed to make so many HTTP requests. You're only allowed to use so many lines of code. You're only allowed to make so many emails per day. Okay, and some of these limits, they don't tell you what they are. So the first thing that we were looking for was how we could push past the governor. Okay, how we could steal more computing time on the Salesforce cloud. And to do this, we'd need to introduce some new primitives into Salesforce.com. Okay, we'd need to find a way to get delays, find a way to get synchronization. And almost all of these can be built just with a little bit of evilness and a little bit of dedication. So what you'll see there is, it turned out that even though Salesforce limit your lines of code, they don't limit how many instructions you put per line. Okay, so with a lot of instructions per line, you bypass a really simple limit. And what we've got there is a whole bunch of mat functions chained together to simulate a sleep. Okay, we basically give it a lot of work. It's going to take a lot of work to do it. We've now got a sleep. Okay, we can then use the database for synchronization. Okay, so we can set a flag. Effectively, we're building a very ghetto-like mutex. Okay, so what we wanted was to have some way to give our code in Salesforce.com an instruction and have it carry on almost forever. Okay, but obviously they're blocking this. What we found though is that with their use of email, we could send an email into the system, have it do some work, then store state in the database once it's reached its limit, and then have it email itself to say, hey, do some work, here's your last state. Okay, essentially what you're creating is a loop inside of Salesforce.com that'll keep going and keep doing your work for you. Okay, once we've built all these things, we've essentially got a loop. We can tell it to do any work for us and it's going to keep doing it. So one of the things we questioned was what we could do for proof of concept, and what we settled on was something called Sifto. Okay, we took the popular Nikto CGI scanner and we ported it into Salesforce.com, so Nikto lives in their cloud. Okay, the thing to remember here is that this is proof of concept. We could have done anything. Essentially, we're using free computing time that now belongs to Salesforce.com. Okay, so if you take a look at this example, and I'm going to go through it really quickly, we've already built up this in Salesforce.com's cloud, and we're using a simple wrapper here so that when we give it a target, it emails that target to our Salesforce application. Okay, and then we're tailing the Apache log file on a victim so that you can see these requests come through. Okay, what you'll see is we kicked off our scan. Salesforce.com now starts sending these CGI requests to our victim, and the moment Salesforce.com picks up a hit in the normal way that Nikto does, it then sends us an email to say, hey, I found this location on that web server. Okay, essentially you're getting the same results that you would from a Nikto test, except this now lives completely on Salesforce.com and is completely free for us. Okay, as attackers who live in South Africa where bandwidth is really expensive, this becomes attractive because it's almost as fast as the lines that we use at home. Okay, but essentially what this means is we can take any application, port it into Salesforce's cloud, and use their computing time to run our applications for us. Okay, so all we're doing there is stealing from Salesforce. Okay, so we're going to steal from a few more vendors really quickly. Quickly, the pros and cons of this sort of attack is it's really simple for us. One of the problems is there are still limits on how many emails you can send. Okay, Salesforce do have it, but it's unpublished. And so what we were looking for was how we could get more accounts from Salesforce.com. Okay, we wanted to sign up for more accounts, and it turns out that on their sign up page, Salesforce.com throw you back a captcha. Okay, so obviously this slows us down. We wanted to automate our way through this, but they've got a captcha. We do a really quick check, and if you look at the stream that comes back from Salesforce during the sign up, what we found, or what Marco found, is down here. They've got a little debug code called S-code, and what they're actually giving you there is the value of their captcha. Okay, so basically with wget, you can read the captcha and automate it. To their credit, we reported it to Salesforce and they had it fixed literally within minutes. Okay, but what it means to us as attackers is we can now scale horizontally. Okay, we can now create 200 accounts and spread our workload with all of those accounts because essentially we're building state fakely. Okay, so this gives us lots of possibilities, lots of interestingness. When you look at something like Salesforce, one of the things that should scare you is that Salesforce don't sell to security guys. Okay, they sell to sales or sell to marketing. And essentially, these security decisions start getting made by C-level execs in your organization. Okay, which should scare you a little bit. We're going to go next to Amazon Web Services. And like I said at the start, something I want to point out is Amazon Web Services is probably some of the coolest technology that I've played with in a really long time. Okay, if you haven't, you should sign up and play with it. It's lots of fun. The pieces that we're going to play with, we're going to look at EC2, S3, SQS, and DevPay. We're not going to look at the rest of them. Because I'm short of time, I'll go through this quickly. EC2, the Elastic Compute Cloud, basically allows you to hit a web page, say I want 10 boxes that look like this. They boot those boxes for you, and suddenly you've got boxes that you can use on the internet. Okay, it's really cool. S3 is their storage service. Basically, they've got, what they say is they're using the storage in buckets. Okay, and what they do is they've got a flat namespace that I'll come back to in a little bit. But if you look at any of the tools, essentially it gives you disk storage that lives in the cloud. You don't have to worry too much about what's happening in the background. It's becoming really popular. Already by January 2008, they were storing 14 billion objects in S3. Yet all of this is stored in a flat namespace. Okay, I'll tell you why I keep going to this, because you're going to see how it's going to hurt them shortly. But basically, if you go onto S3 and you create McCulver images, everything after that that sits under that belongs to you. And there's no limitation on, or there's very few limitations on what you choose as your S3 name. Okay, SQS, it's a normal, like abstract data type. You've got a queue object that sits in the cloud, allows you to pop stuff and push stuff off it. Works just like a normal queue does, except Amazon hosts it for you. Okay, so when we were looking at what to do, I wanted to find out what coolness we could get from Amazon. The simple thing to do is to do what Marco did. Let's see if we can steal computing resources from Amazon. Okay, and the easy answer is yes, we can. Okay, so if you look at how Amazon Web Services works, you go to a web page and you say, which of these boxes shall I boot? You click on a box and you boot it. Okay, what's interesting is if you look at the number down here, okay, there's nearly 2,800 images. Okay, Amazon only built 47 of them. The rest have been user contributed. Okay, so typically when someone goes to Amazon and they boot one of those machines, chances are they're probably booting a machine that was built by Joe Public. Okay, they've got no way of knowing what's on those machines. So we wanted some way to scan them, but of course, Amazon won't let you scan in their cloud. Okay, so it's almost like we've taken a step back. We weren't quite getting things right with Qualys and scanners like that, trying to scan our network, and now we're building networks where we're not allowed to scan them to begin with. Okay, so it's not great for us. So what we did really quickly was built a really ghetto scanner, where what our scanner does is it goes onto the internet, goes to Amazon, and gets a list of all possible machine images. Okay, Amazon then limits you to 20 machines, so we fire up 10 instances. Each of these instances then fetches from the SQS queue and says, give me another image. We then fire up that image and scan it. Okay, and for scanning here, we did really simple stuff, so we Nessus scanned it, and we did some file system checks that we were interested in. Okay, we then take those results, populate it into an S3 bucket, and read those results off. Okay, what's interesting is, just from that initial scan, you find at least 1,200 high, 700 just about critical vulnerabilities on those boxes that are now living inside of Amazon's cloud. What's more interesting than that for us is this screen, which you probably can't read at all. Okay, so what we're doing here is we're going into every image that we fire up, and we're looking on the file system for interesting files. Okay, where we define interesting as people's bash history, people's private keys, people's Amazon keys, and what you get is all these pages and pages of private information that's still left on those Amazon images. Okay, all of these are the Amazon keys that Amazon used to identify you. So clearly what's happened is people have created images, but not taken their private credentials off those images before sharing them with everyone. Okay, so you could just go onto Amazon, fire up these images, look for private information, become someone else, and then use their computing time. Okay, while we were stealing, we figured there must be a better way than just robbing Amazon's customers, like the last attack did. And instead we said, let's see if we can rob Amazon directly. Okay, which takes us to really simple license stealing. Okay, so Amazon also give you Win2K3 images. Okay, if we fire one up and then use the very elite Magic Jelly Bean tool, Okay, basically what Magic Jelly Bean does is tells you what your running registration information is. So we go there and we extract the license key from one of Amazon's Win2K3 images. Okay, we then take this license key back home, put it on our server, and it happily works. That server also happily still Windows updates, so it passes Microsoft's genuine advantage. Okay, so essentially anytime we need a Win2K3 license now, we fire up an EC2 image, steal the license from there, and SensePost can now run Win2K3 servers. Okay, but the question is, do we have to stop there? And in truth, we don't. Amazon also have some system called Amazon DevPay, which means you fire up an Amazon image, and every time someone wants to use your image, they'll pay money to you. Okay, so you can see it's really cool. If I've got some technology that I want to share, I build an image, I register it with DevPay. Whenever you fire it up, you'll pay me money. Okay, the money funnels through Amazon, but essentially that's what the model is. Okay, so what we were interested in was to see if we could attack this so that we could steal resources or use resources without paying for them. Okay, and if we look at this video really quickly, okay, so that's the normal Amazon DevPay process. Nick's gone, created an AMI, registered it with DevPay. Okay, what you see up here is the product code. Okay, so anytime I use this product, the product code is now associated with it, which means I have to pay Nick. Okay, so if I try to boot this image, okay, using AWS, and what I'm going to do here is try to boot it on the command line. Okay, the machine is now running. What you should see down here is that there's a product code associated with my running image, which means that as long as this image runs, Nick's going to get paid for it. Okay, so obviously what I want to do as an attacker is somehow remove that product code. And so what I do is I rebundle this image. Okay, so I take Nick's image, which I have to pay for, I rebundle it, and I upload it to the cloud again. Okay, and for demonstration purposes here, I'm uploading it twice so that we can experiment. Okay, and the first time that I upload it, I'm basically going to call it copy 1, the second time copy 2, just because I'm not that imaginative. Okay, and then what I do is I take this image and I edit the manifest file. Okay, so there's a manifest file that goes along with this image that says this is what the image comprises of. And what you'll notice in this manifest file is that it carries around its ancestor ID. Okay, so all we do is we go in, we remove its ancestor ID so that it's got no ancestor, we re-upload that to Amazon, and then we try to run it. Okay, and what we find, sadly, is that it fails. Okay, and that's because Amazon comes back and tells you, this image has an invalid signature, are you sure you're the machine owner? Okay, so it's pretty simple, they're doing some sort of signature check on it. So we go back and look at that manifest file, and remember all of these tools that bundle images and upload images are sitting on your machine. Okay, so if you look through these tools, you'll find Ruby code that generates that signature. Okay, so all we do now is we find that Ruby code, we then take our new manifest file with the ancestry removed, we run it through our script so that it now re-signs that file, and we upload our newly signed file to Amazon, and now Amazon accepts it, and now Nick no longer gets paid. Okay, so essentially, we download his image, remove the ancestry, re-sign the image, and upload it, and from now on, Nick's no longer the owner of it, I'm the owner of it, and I can keep using it. Okay, and what we see here is, even though we stop paying Nick, we're still happily able to run his image. Okay, if we go back here. Okay, the other thing that's interesting with Amazon Web Services is their big push is their availability. Okay, they basically tell you, Amazon knows uptime, Amazon knows DDoS, so use us. Okay, and they do point out that they can handle DDoS like nobody else can. Okay, the problem is DDoS is really not a 2010, 2009 problem. Okay, there's lots of other ways to create a denial of service situation without sending lots of packets to Amazon. Okay, Amazon are aware of this, so one of the things they do is they restrict you to only firing up 20 images. Okay, you can't fire up more images than us. But of course, one of the things that we figure out, and I'll skip the video, is that we can automate the sign-up process. Okay, so again, using Twill and about 5 minutes of coding, you can automate it so you can say, sign me up for 30 accounts. Okay, and then each of those 30 accounts now have the 20 limit. Okay, but you can see where that problem is going. Okay, so we timed our script, and in 3 minutes, if we run it, it can create 20 accounts. And if we run that script in a loop, each of those 20 accounts then fire up 20 machines, and each of those machines create 20 accounts that fire up 20 machines. Okay, and you can see that this is going to scale, and essentially after 9 iterations at 3 minutes each, you would have fired up something like 8 billion images on Amazon's cloud. Okay, it doesn't matter if they're doing DDoS protection, this will drop them, bring them to a grinding halt. Okay, another way for us to steal images, if we're looking really simply, is Amazon basically tell you, you're about to log into this machine, please make sure this machine is safe. And they give you 5 bullet points that say, this is how you know it's safe. Check the SSH authorized key file, check for running services. Okay, all our years of incident response has now come down to 5 bullet points. 6, make sure that all cron jobs are legitimate. Okay, which obviously is going to be a really poor way for you to tell that a machine is safe or not. So what we wanted to do is build an image, make it evil, upload it to Amazon, and see if people would run it for us. Okay, so we thought it would be really simple. Bundle one, throw one up there. The moment you register it, Amazon give you an AMI ID. We wait till someone runs it, and we declare victory. Okay, alas, the problem that we have is that this image sits literally nowhere. So we create this image, we upload it. Okay, that's just the process of uploading it. We wait, and what we find is that the image never gets run. Okay, it's not just because we're from South Africa. On the internet, nobody can tell this. Okay, but what happens is once we create this image, and upload it, okay, I'm going to skip through it really quickly because once again we're short of time. What you find is if we go to just our images, there's our image that we've loaded, and you'll find that this image is sitting on page something like 60. Okay, so once someone hits the Amazon page, they've got to scroll through right down to like the 2000th image before they find us. Okay, and that's why nobody is running our image, because it shows up too late on Amazon's rankings. So instead what we do is we write a really simple Python script. And all the script is going to do is it's going to register an image, take a look at the AMI ID that Amazon gives us, and if the ID is too high, we're going to deregister that image. So what we're hoping to do is that sooner or later, Amazon will give us a low registration number. Okay, so the first time we left this running for about 12 hours, okay, and eventually it came back after 12 hours, gave us a hit that puts us on Amazon's front page. Okay, the second time we ran it, it took us only 4 hours. But essentially, because it cycles around, sooner or later you're going to get an image number like this one that now shows up on page 1. Okay, so the moment someone goes to page 1, they're now going to see our image. It increases the likelihood that someone's going to run it. Okay, but so while it transforms. Okay, so keep in mind what we've done is we've put up an evil image. We've now promoted that image so that it's on their first page. Okay, but there's more. Okay, you'll remember I told you that part of the problem was that S3 was using a flat namespace. Okay, so we can also name that image anything we want. Okay, so for the first thing that we do, and it's pretty much like the DNS name grab that happened, is we try to name our image Fedora. Okay, turns out Fedora is taken. We try a bunch of names until we figure out we can actually use hyphens and underscores. Okay, so we name our image Fedora underscore core underscore 11. It happily creates it on S3. We then run the promotion script that keeps registering and deregistering this image. And what we end up with is, on page 1, it's probably the 11th box, Fedora_11. Okay, so now the first Fedora image that anyone finds if they hit Amazon store is our image. Okay, that only has to run for a few minutes before that box starts getting booted. In our case, we just have the box call home to us and say, I've now booted, but it could have been doing anything. And essentially, other people are running our box for us. Okay, I'm going to blitz through this really quickly. Firewalling on Amazon. If you go through the user forums, you'll see an internet win. Someone saying, how do we block outbound connections? Some Einstein responds with, why would you want to block outbound connections? Okay, so all these years of internet computing, we've now taken a massive step forward. Skip through that video because we've got 3 videos and no time. But basically, if you go to MobileMe and say you forgot your password, the first thing they're going to ask you is your birth date, and then they're going to ask you your secret question. Okay, and you can find this out for almost everyone relatively easily. If you can't find them on Facebook, you'll find them on Amazon with their birthday list. Okay, so if you take for granted that we can reset people's passwords relatively easily on MobileMe, the next question is, what do I do once I'm able to reset your password? And for this, we actually looked at an attack that's semi-weird and a little bit counterintuitive. Okay, so what we're going to look at here is an attack that's not going to make too much of sense until we take it all the way. And basically what you find is if you sync your phone with MobileMe, okay, you're in a position basically to use the forgot my phone feature. Okay, so Apple's MobileMe now says, hey, here's where your phone is located, blah, blah, blah. Okay, and what you'll notice is Apple take the name of your phone directly onto that application. Okay, so what we found is if you go in and name your phone script alert hi, so you insert some JavaScript into your phone name, you'll find that that script goes through and actually tries to get rendered on the Apple MobileMe page. Okay, here you're going to bump into some technical difficulties, which is basically that Apple's MobileMe page, not for security because Apple wanted it to look nice, truncate the name of your phone. Okay, so in a bunch of places, even though you put a lot of JavaScript in it, they're cutting down that JavaScript. Okay, and what we find is actually they cut it down in 3 places, and in 2 places they don't cut it down. Okay, so all our JavaScript that we put in our phone name can go to the MobileMe page, except some of it's getting cut off, and so some of it's breaking their page. Okay, so we now start trying to see how much of JavaScript we can squeeze into that small space, and it turns out that you can't. Okay, you can't do anything useful in that smaller space. And it turns out the answer is not to use really small JavaScript, but to use a lot of JavaScript, but pad it initially with something non-malicious. Okay, so whoever truncates it, truncates stuff that doesn't matter, they're truncating the padding, and the ones that don't truncate basically allows our script to go through. Okay, so we put in a whole bunch of JavaScript that looks something like that. I'll skip through it. And essentially what it means is that now, anytime someone goes to the web page, anytime someone goes to this MobileMe page, the JavaScript that we put in our phone name now runs on their MobileMe page. Okay, which again sounds pointless or slightly pointless, because it now means that anytime someone goes to this page, they now get owned with whatever script we put on our phone, which takes us really quickly, I see that my time is almost up, to probably the last version of this. Okay, so we were looking for someone reasonably high profile that wouldn't get too upset with us. Okay, and if you take a look at the art of deception, controlling the human element of security, we decided not to pick on Kevin Mitnick again, because that's done. But you find that Steve Wozniak wrote the intro. Okay, and he spoke about how basically spoke about the human aspects of security. If we try to find Wozniak on iDisk, we can use the normal way. So you search for Wozniak, comes back and says the account doesn't exist. Okay, Steve Wozniak comes back and says that doesn't exist. Okay, and probably what we should have guessed from the outset was was. Okay, comes back, says was's account actually exists. If you play around in the account, okay, that's his public files, so haven't attacked him yet. Okay, and what you'll find is he's got some sort of photo library that sits there. Okay, you'll notice the photo takes a long time to download because we're in South Africa. Okay, but essentially what you figure out is that this is definitely the Steve Wozniak. Okay, so that's from his photo gallery. Okay, so what we do then is go into his mobile me and say, I'm Woz, I forgot my password. Okay, it says, what's your account? Woz, we've just guessed. Okay, it comes back here and tells you that the alternate email is at woz.org. So we already can confirm it's definitely Wozniak. Okay, like I said, mandatory question, verify your birth date. Okay, not particularly challenging. If you do any sort of Google for him, you're going to find his birth date relatively easily. Okay, so once you put in his birth date, that's going to come back with the secret question. I'm going to skip through this quickly because I'm in overrun mode. Okay, that comes back and says, what's your mother's maiden name? Okay, also going to be particularly hard on the interwebs. Okay, so if you go there, comes back, tells you his girlfriend, also tells you his mother's name. Okay, so you put it in, it's Kern, for those of you who cared. Okay, and at that point, it allows you to reset his account. Okay, you then use the first attack that we spoke about, which then allows me to sync my phone with his. Essentially, I have a way to insert JavaScript into Woz's page whenever he views his page. So from now on, anytime he visits his page, anytime Woz visits his page, what he should see on his locate me is something like this. Okay, but essentially, we can put anything in there so that anytime he goes there, he sees what he thinks is valid, but his mobile me always calls home to us. Okay, at the time we mailed him and he mailed back. He's actually quite cool about it. But what's interesting to note here is we keep going lower and lower when we talk about Trojans, okay? We went from Trojans, we went to kernel Trojans, we've now gone to SMM rootkits, okay? But a rootkit like this is literally a rootkit written in JavaScript that lives inside of Woz's mobile me. It doesn't matter what he does or where he goes, every time he logs into mobile me, his mobile me is going to send us his current credentials. Okay, so it's actually taking a Trojan and moving it higher up in the stack rather than lower in the stack. We all laughed at XSS initially. We all called it a bit of a lame vector. But actually, with where we're going, it's starting to become more and more important. Okay, so really quickly, I won't go through all of this. You can read it. You can read it on the slides. Essentially, the things to remember are, we didn't fix the web app problems. We're now making those web app problems the stuff that controls our infrastructure. We didn't fix, we've got a lot more problems that we need to start looking for, lots of attacks that aren't the traditional attack vectors that now come into play once we're talking about the cloud. We're moving into the cloud whether we want to or not. So even if you don't know your stuff's moving into the cloud, lots of vendors are moving you automatically. Transparency is going to be key. Testing is going to be key. All of the vendors that we spoke to were really responsive. In fact, Salesforce.com have since come up with a model where they put up a box and let you hack it free so that they can make some steps towards transparency. Of course, they're getting free auditing for it, but it's a good move. Transparency is going to be important, and Steve Wozniak is cool. The videos, the slides, the tools are all available on our website. You can mail research@sensepost.com if you've got any questions. Like every man and his dog, I'm on Twitter, so you can follow me and get questions there. Any questions?
Unfortunately, if you don't mind, Mr. Meer, we'll have, can we do questions off the stage if you want to approach Mr.
Sounds good.
Excellent. So please feel free to approach him directly. We would now, in the interest of time, would like to move on to the next talk. Thank you very much, Mr. Harron Meer.